Welcome. In this video I'm going to show you how you can obtain the mode for bin data using R. I'm using Jupyter Lab with R kernel, but this code should also run in, for example, R Studio. I'm using R version 4.3 and this video will focus on how to obtain the mode and not so much how to obtain the bins itself. How many bins, I have separate videos on that. I already loaded my data. It's coming from the General Social Survey from 2012. I adjusted a few things sometimes for example purposes. I don't need all of its data, I just need one numerical field. So I've chose age as the field. I remove any missing values. And since there's one category in there of 89 or older, I just replaced those with 89 and then made sure everything was numeric. In a separate video, I show you how this can be done simply with my own library, which simply has a function that can do this. But in this video, I'll show you how you can do it without. So the first thing I need are the bins. So I'm just going to be using these bins, and I'm going to set the lower bounds and the upper bounds of those bins as a separate data frame. I'm going to sort all the scores. So that's easily done with sort, and then I need to obtain the count for each of them. So here's just a simple loop that keeps on going over and keeps on counting, and apparently there are 32 in the first bin, 138 in the second, etc. However, we need frequency densities, which is if your bins don't all have the same width. So that's simply the frequency divided by the bin width or the class width. And the class width is the upper bound minus the lower bound. So I first determine those class width, and then I simply divide the counts by that class width. So these are my frequency densities. And then the mode is actually the bin with the highest frequency density. So I'll determine what the maximum frequency density is with the max function, and then I can use a which, and then this will give me the index of which bin was actually the mode. And if there's more than one, it will return actually also a list of more than one. So the third bin was actually the mode. So I can then just look up from my bins what the lower and the upper bound was. To actually do that, what I first do is I check if not by accident this returned the same amount as numbers in it as the number of bins, because then all of them have the same frequency density, which then probably means that there is no real mode because none of them is higher than the others. And otherwise, it's actually going to look at for each of them the lower bound and the upper bound, and nicely writes that down. So in this case I have 25 to 30. That was actually the mode. Instead of reporting the bin itself, we could actually also report the midpoint. So that's the average of the upper bound and the lower bound. So you add those two and divide it by 2. So we do that for each mode that we might have, and we simply say, well, it's going to be the upper bound plus the lower bound, and then divide by 2. So that should give us, in this case, 27.5, which is indeed exactly between 25 and 30. There's also a complicated quadratic method that tries to smooth the data a little bit. I notice here there's something wrong with my fraction. That's because there's a additional O. So, and this is what that formula looks like, where D1 and D2 are based on the frequency densities, but also of the group prior to it, and the frequency density of the group after it. So this is actually what it's trying to do. It's trying to like smooth the data like this, and then try to find this point, and that would then probably be the mode. So that's all being done in here. So the mode's quartile point, and this is simply running that formula. So let's have a look what that returns. So in this case 26.23. So that's a little bit lower than that 27.5. Here's all the same code again, but then for if there's a scenario where we have different scores like these and where there's more than one mode, then apparently 5, 25 and 45 are the mode midpoints. And if we wanted to see the quartile versions, the 6 2/3, 25 and 43 1/3. Alright, I hope this video was helpful and thank you for watching.